Welcome to Python for Scientific Computing 1. In today's video, we'll talk about while loops. As with for loops, while loops also see widespread usage in numerical analysis. In today's video, we'll look at the logic behind while loops, talk about the syntax of while loops in Python, as well as identify some pitfalls that we need to be aware of when implementing while loops. A while loop starts with a test expression. If the test expression is true, you enter the while loop and the code block associated with that while loop gets executed. As part of this execution, the test expression itself gets altered. So at the end of the code block, the loop goes back, tests the expression because now it has new values for the test expression. And if that test expression still renders to be true, then the code block is computed again. And this computation will again change the test expression. So at the end, it'll go back and test the test expression again. And it continues doing so till the test expression is rendered false. Once the test expression is rendered false, the loop exits and the code proceeds to the next statement that's immediately follows the loop. A while loop is typically used when the number of iterations is unknown because the criteria that is causing us to exit that loop is being computed inside the loop itself. So let's look at the syntax of while loop. What I want to do in this example is take a number that's below 1000, continue dividing that number by 2 till the new number that I obtain is less than or equal to 0.5. I want to write the sequence of numbers that arise from this process. Also, I want to stop after 12 iterations regardless of the outcome. To start this example, I'm going to start defining a value of x, which is equal to 99. I'm going to also initialize an index idx with a value 0. And then I'm going to initialize an empty array called num. An empty list can be initialized by using open and close square brackets. So coming to the while loop, I'm going to say that while my x is greater than 0.5 and my index is less than 12 because I want at least 12 iterations and I'm starting with an index of 0. So less than 12 means I'll go from 0 to 11, which are 12 iterations. And then as long as my x is greater than 0.5, I want to continue dividing that number. And I want to divide that number by 2. And then I'm appending that number here into this empty list num. And then I'm going to increment my index and keep moving. So notice that my while loop requires me to evaluate two expressions. One that is x greater than 0.5, so there is a variable x involved, and idx should be less than 12. So idx is another variable that's involved in the evaluation of this test expression. The AND implies both these conditions have to be met for the expression to render true and calculations to move into the loop. Notice that I'm also changing my x inside the while loop, and I'm also changing my idx inside that while loop. So both the x and idx get changed after each iteration of the loop. So I start with 99 and index of 0. Clearly 99 is greater than 0.5, so this condition is satisfied. And also, since my index is 0 and the index 0 is less than 12, this condition is also satisfied. As both the first and the second condition are satisfied, I enter the loop. I take my 99, divide by 2, so I get 49.5. I'll append the number 49.5 to my list, empty list num. And then I'm going to increment my index from 0 to 1, go back. Index is still less than 12. 49.5 is still greater than 0.5. So I go down, I divide by 2, I get 24.75. I add that number, increment the index, and I keep doing this. So once my x becomes less than or equal to 0.5, or my index becomes equal to 12, then this condition will not be met and I will have to exit the loop. So it turns out, as I start with 99, I've completed 8 iterations, which are less than 12. So, which means that the number rendered itself to be less than 0.5 before the maximum number of iterations were performed. When the number turned to be 0.77, it came in, it saw that 0.77 is greater than 0.5, and and that was the 7th iteration, so this was also met. It went in, divided that 0.7734,375 by 2, which gave me a value of 0.368. The next statement here is it appended that value to X. So it went and appended 0.368 to my list, incremented my index to 8, and came back up. And when it came back up, what happened is it saw that my X is greater than 0.5, but my X was 0.386. So it essentially did not meet this criteria. My index was 8, so 8 was less than 12. So this criteria was met. However, since this criteria was not met, it went no further into the loop and stopped there. So that's why we have this statement, and this statement terminated when the value of X became 0.368. Now, if I didn't want that 0.368 to be written, what I could have done is I could have put an if statement and said append only if my X is greater than 0.5. However, this illustrates that since I'm using the append with my previous value of 0.773, it got the new value, appended it, and then it kept moving forward. If I had just moved this num dot append to the top, what would have happened is this number would not have gotten appended. And you can check that as part of your exercise. Let's look at another example. In this example, I'm making use of two libraries. One library is the math library, and the other one is the random library, which generates random numbers. And I'm going to bring in the random library with an alias of RND. I'm going to initialize my index to be 0, and I'm going to initialize my R to be 0.51. And I've also initialized two empty arrays, one called num and one called rx, both of which are empty lists. Okay. So my while statement says that when r is greater than 0.3 or my index is less than 20, if one of these criteria is met, what this or statement is saying is either this is met or that is met, I will go into the while loop. Then what I do is I'm starting with 0.51, so 0.51 is greater than 0.3. And my index is 0, so index is less than 20. Both of them are being met, so it moves into this, creates a new random number, and then it performs a calculation. It takes that random number, multiplies it with 3.14, which is math.pi, and then it takes the square root, which is math.square root. Every time I put math dot, it basically means that I'm pulling a function out of the math library. Similarly, if I put rnd dot random, I'm pulling this random function out of my rnd library, or which is the random library that I've aliased as rnd. And then I take the sign of it. So I'm basically taking r, multiplying it with pi, taking the square root of it, and then taking the sign. I'm doing a sequence of calculations. And then what I'm doing is I'm taking that number, rounding it to 3 decimal places. And I'm also taking this r, which is the random number that I generated, and rounding it to 3 decimal places. I'm going to append the r, append the number that I calculated, update my index, and go back. So now I have a new R, not 0.51, but the one that I created here. And then I have a new index, so I can go back and check if this condition is met, and it will go on doing it. Even if this R were to be greater than 0.3, as long as my index is less than 20, it will keep doing this calculations. So I'm assured of at least 20 calculations because of this IDX being less than 20. However, if my R continues to be greater than 0.3 past this 20, even though this IDX is not met, the R condition will be met. So in theory, I could have more than 20 iterations happening. Such is the case here, where I've had 26 iterations, and the random values that I got were all these 0.038, 0.972, so on and so forth. And you can see that, and then the values that I computed for NumMy were all these little values that I got. And as you can see, I have 26 iterations, so 26, 27, 25, 24, 23, 22, 20. So zero point 0.6 is clearly greater than 0.3, 0.7 is greater than 0.3, 0.91 is greater than 0.3, 0.308 is also greater than 0.3, 0.449 is greater than 0.3, 0.826 is greater than 0.3. However, when I went to 0.224, 224 was less than 0.3 and my IDX was 26. So neither one of them satisfied. So it exited the loop and came back. Again, this 0.224 got written because I appended it before I left the loop. So I got the new numbers, appended it, and then used those numbers to check. That's why this number exists there. You can also use a while loop as a for loop. The way to do that would be to make use of an index again. So I have a list A up on the top that I want to iterate over. Then what I do is I calculate the length of A using the len function, and given is n. I initialize my index to be 0, and I also create an empty list to add new values. And then in my while loop, I say while idx is less than n, because I'm going from 0, I need to go up to n, but not quite to n. So I'm going to put idx less than n. It'll keep on going till one number before the n value is reached or the length of the list is reached. I pull out the value using this idx or the index, add 10, create a new value, append that value, update my increment, and keep looping. So this loop will terminate once the last element of the list is reached. So this is how you can use a while loop as a for loop. One of the problems with using while loop is there is a possibility that you will get stuck into an infinite loop trap. The famous computer scientist Alan Turing mathematically proved that you cannot create a machine that can go into the infinite loop, shut off that infinite loop, and come back. Okay, which means that if something goes into the infinite loop, it'll be stuck in that infinite loop. So if you were to have infinite loops, only thing that will happen is your computer will either hang up after a while or your system will crash and then you will have to reboot. So the reason for this typically is a syntax or a logic error, and it's quite possible this happens because the condition that you're using to get out of the loop is never being met. Making sure that you don't get into this infinite loop trap is very easy. Simply put a condition that will get you out of the loop after a reasonable set of calculations. So you simply have to put an if, create a new conditions, typically the number of iterations or the time that it takes to make these calculations, and then break once that condition is met. So let's look at an example of an infinite loop. I'm again importing the random library as RND, and I'm going to create a random number R. This random number R goes between 0 and 1, both inclusive. So the numbers are always positive, and the numbers are always greater than or equal to 0. So I'm going to get a value of R that is greater than 0 or equal to 0 here. And then my index is equal to 0. I have an empty list X that I want to append. I go here and I say while R is greater than or equal to 0, this condition will be met because the R that I'm going to create here will always be greater than or equal to 0. So it will enter the loop. And then when it enters the loop, it's using that R to create new value called AX. It's going to append that value of AX, increment my index by 1, go back to the loop. Notice R has not been changed. So because R has not been changed, it will use the same old R which it used to enter the loop, which means if it entered the loop last time, it's going to enter the loop again, and then it'll perform these calculations. Even if I were to put this function R is equal to rnd.random here, it won't make a difference because what is happening is that value of random number that it generates will always be greater than or equal to 0. So this condition will always be met. If this condition is always met, there is no way for you to exit this loop. So the computer will simply keep iterating till it runs out of memory, and then it stops. One way to avoid this is simply put a get out of infinite loop criteria. So what I do is, again, I write the same thing. I'm importing random as rand. I take my IDX to be 0. I initialized an empty list to put new values. And I go here and say r is greater than or equal to 0. This condition still holds true. It is just like here, right? It'll always be met. Then it goes and calculates this rx, which is r squared over 2, calculates this ax, which is basically it rounds that number to 3 decimal places. It appends it. Then it increments the index by 1, creates a new random number. And as I said before, even if the new random number is created, there is still no way for me to get out of this loop, because the new random number that I'm going to generate will always be greater than or equal to 0. Because of that, this portion of the loop will continue. However, the next line I'm saying if IDX is equal to 100, then I'm going to say print performed 100 iterations, quitting now, and then it breaks out of the loop. So it breaks out after 100 iterations. So this is one way in which, even though we don't have anything changing here, we are essentially putting an if statement and breaking out of the loop. This is one of the very common uses of break statement. The break statement is used more so in a while loop than in a for loop to essentially break out of the possibility of getting stuck in an infinite loop, or break out if some other condition that is not part of our evaluation condition is met, and then you can break out at that point. So that is what will happen. Putting an if statement with a break statement always helps you avoid these infinite loop possibilities. Sometimes you might not have an infinite loop. For example, if I put r greater than 0, I can get 0 as part of a random number. So, but my chances of getting 0 are virtually 0, because between 0 and 1, there are infinite random numbers, and the computer can randomly generate any one of those. So the probability of getting 0 is really minuscule, but nonetheless, in theory, it won't be an infinite loop, but that loop, for all practical purposes, will run for a very long time. It'll practically be infinite. So sometimes you don't have to have a logic error to have an infinite loop. It's possible that you have a loop that goes too long and you want to end that loop at some point in time. While loop also shares quite a bit of similarities with if statement. They both evaluate a Boolean expression, and if that condition is true, then the code block is executed. The if statement will execute the code block only once, while the while loop goes back and checks if the condition is true, and then executes it again and does so till the evaluation condition turns out to be false. So the big difference between if statement and while loop is that the if statement expression is only tested once, and then the code loop is only executed once, whereas for the while loop, the code block is executed more than once, or has the potential of being executed more than once. In summary, while loop is another useful tool to work with data sequences. We use while loop when the number of iterations is not known. For example, working with random numbers or performing successive calculations till we reach some accuracy. While loop can also be used as an alternative for the for loop. Generally, we use for loop when we know the number of iterations a priori. It is similar to an if statement in that a Boolean condition is evaluated, but while loop evaluates this more than once, or at least has the potential to evaluate more than once, while the if statement only checks it once. The potential for being stuck in an infinite loop is very real with while loop. So always check your syntax and put a get out of the loop condition just to make sure that you're not getting stuck in an infinite loop, or a loop that takes too long to run without producing anything. I hope you found this video useful. I will see you in the next video. Till then, take care and goodbye.